Hey everyone, welcome back. Today we're going to be going right into section 1.3, solving equations with both sides. Now with all of these problems that we do, we're kind of, I guess we could say, side loading a lot of concepts here. So the one that we're looking at here is perimeter. Now this isn't a perimeter lesson, but we're trying to teach a little bit about perimeter as we go along. So as we know, a perimeter is a distance all the way around a figure. So if I take a look at this figure on the left, if I wanted to find out the perimeter, I would have to go ahead and get this length right here, add to that this right here, add to that this right here, this length, add that, add this length, and then add this length. So we can get the perimeter. Let's add all of those sides together. I notice looking at this figure that every side does have an expression with it. So we'll just go ahead and say, well, this is going to be x. The perimeter equals x plus 5 plus 2 plus x plus another 2 plus another 5. Now you saw me circle all of the sides, and that's just to make sure that I don't double count anything. And it also helps me make sure that all the sides actually have a length attached to it. So I'm going to combine like terms here, and I'm going to look for all the linear terms, x and x. Remember, that's 1x plus 1x, so that's 2x's. And then we can go 5 plus 2 plus 2 plus 5. I think that's 14. And that gives me a nice simplified expression for the perimeter of this first figure. Now the second figure is a little bit more difficult. Let's see if we can figure out all the sides. Well, we got this one right here. That side is 3/2 x. You can think of that as 1.5x if you want. This one right here is 5. This one right here is 4. And now you might think I'd want to jump right over to 3 over here, but that's going to skip a side. I don't know how long this side is right here. Well, one common trick in order to figure out that side is to think, well, if this side, this length right here, let me highlight this together. This right here plus this right here, that has to equal 5. Well, what is this? This is 3 plus an unknown length. We don't know what that is. I think it's pretty obvious here that the thing that we have here is going to be 5. Or I'm sorry, is going to be 2. So this side right here, we'll just call that a 2. Okay. Now we're going to take that same principle. Let me clear off over here and do something else with it because we have another side here that we don't have a number attached to. Let's see. We've got this side right over here. And if I take a look across here, I've got 3/2 x, and I've got this one right over here. So the two yellow sides across the bottom should equal to 3/2 x. So let's go ahead and write that down. 3/2 x. That should equal to the unknown side plus 4. Okay, so what is that unknown side then? Well, we're going to have to do a little bit of algebra to solve for that. And the little bit of algebra is, well, we're going to subtract 4 from both sides of the equal sign here. Let's subtract 4. Like we said in the last few lessons, this is a 0 pair. And so my unknown side is just going to be 3/2 x minus 4. Okay, so we're going to put that right over here. Actually, let's move this expression just to give us a little bit more room. 3/2 x minus 4. And I'm going to put that in parentheses because there's a minus sign there, and I want to make sure that I treat that correctly. Well, as it turns out, there's a plus sign in front there, so I actually don't need those parentheses. If there's a plus sign in front of a parenthesis, this parenthesis is, well, not needed. So this perimeter is, well, let's count all of the linear terms. The linear terms are 3/2 x plus 3/2 x. If I add that together, that's like 1.5x plus 1.5x. That's 3x. If that doesn't make sense to you, make sure you use your calculator to add that together. Okay, so that takes care of all of the linear terms. Let's look at all the constant terms. You got a 5. 5 plus 4, that's 9. 9 plus 2, that's 7. No, sorry. 9 plus 2 is 11. 11 minus 4, that is 7. So that's just 3x plus 7. Those are my two perimeters. Now, the second part of the directions here are to, well, the two polygons have the same perimeter. So these two quantities, right here and here, those are equal to each other. So we can say that 2x equals 3x, actually I wrote that wrong, 2x plus 14 is equal to 3x plus 7. And with this equality, we should be able to figure out what x is equivalent to. How much is x? Okay, so we'll notice that we have the linear terms on the left and on the right. That's not good. What I like to tell my students is to figure out which one of these is smaller. Is 2x smaller or is 3x smaller? And 2x should be smaller. So we're going to go ahead and get rid of that 2x by using a zero pair. So we're going to write minus a 2x on both sides. Here's that zero pair. That's going to make a 0. So I'm left with 14 equal to 3x minus 2x, that's 1x, plus a 7. And then we can again subtract 7 from both sides. We want to do that because I want to know the value of x. Okay, so keep your eyes on the prize, as they say. You want to know the value of x, so you want to move everything away from the x. So that means that x equals 14 minus 7. Here's that zero pair again. So x is equal to 7. Okay. How about the perimeter of the two figures? Well, of these two, I think we'll figure out from this. Figure out from the one on the left. The perimeter is equal to 2x plus 14. So the perimeter is equal to 2 times 7 plus 14. And you can grab your calculator or whatever you want, but that's going to give you 28. So the perimeter is 28 and x is equal to 7. So that solves this problem. Remember, the only big advance that we did here was seeing an equation with a variable on the left and the right. Everything else is going to be kind of the same. So here's another one where you're supposed to find the perimeter. So let's just do this one. Let's figure out the perimeter. Okay, this side right here, that's x. So we'll say the perimeter equals x plus, okay, the next side over here is 1. So we'll put a 1, x plus 1 plus, the next side here is 5. So plus a 5 plus, the next side over here is also 5. So plus another 5. And then the last side over here, right over there, that doesn't actually have a side to it, or a number attached to it, but it should be the same as whatever's across to it. That should be equal to 1. So that tells me that the perimeter is equal to x plus, let's see, 1 plus 5 is 6. 6 plus 5 is 11. 11 plus 1 is 12. So this perimeter is x plus 12. Now the only other one that's kind of weird is this one right here. And I'm going to go ahead, I'm going to draw across this over here because whenever you see a circle, the most important part of the circle is the radius. So we can see here that this top half is actually meant to be circular. Okay. So there were a few things that we're supposed to know about circles coming into class, which maybe you do, maybe you don't know. But one of the things you're supposed to know about a circle is the circumference is equal to 2 times pi times the radius. Okay, in our case, our radius is going to be 2. So it's going to be 2 times pi multiplied by 2, which is 4 pi. But that's for the whole circle. We only have a half circle. So the half circle is the half circumference. That's going to be half of 4 pi, which is just 2 pi. So this right here is 2 pi. Okay, let's get our perimeter. We've got this segment right over here. That's an x. Perimeter is equal to x plus. Now the next outside piece is that circular piece. It's going to be kind of hard to see that because I'm trying to highlight it in yellow and green at the same time. But that piece is 2 pi. Okay, let's go to the next piece here. This is right over here. How long is that? Well, that's across from an x. So that's also going to be x plus. Now the last piece is right here. Well, how long is that? And to do that, we're also going to look across the way. And if this piece is 2, then this piece over here has also got to be 2. So we're talking about 4. So the perimeter is equal to, let's see, 2x plus 2 pi plus 4. So that's our perimeter. If you wanted to substitute here for pi, you know that pi is approximately equal to 3.14. So if you prefer, you can probably say 2 times 3.14 plus 4. So I think that's equal to 2x plus 10.28. 10.28. You know what? I really shouldn't do that. 2 times 3.14 is 6.28 plus another 4. So the perimeter is 2x plus 10.28. Okay, approximately actually, because as soon as we say that pi is 3.14, that's all an approximation. So let's move on down to the next section here, which would be note-taking, which would be what is each vocabulary term. Identity is something is equal to itself. Is equal to itself, always. Okay. And then now this is meant to be, when you see core concepts here, this is the part that you really need to pay attention to because this tells you how to solve the problems. So to solve an equation with variables on both sides, the first thing we do is simplify both sides if necessary. Now when we simplify both sides, we're trying to get the sides down to something that's like ax plus b, linear times variable plus constant. Okay, and that has to happen on the left side and the right side. Next, we're going to use inverse operations to collect the variable on one side. It doesn't matter if you collect the variables on the left or if you collect the variables on the right. Finally, you're going to use inverse operations to solve for the variable, and this is what we did in sections 1.1 and 1.2. So notice how this section 1.3 builds on what we did in 1.1 and 1.2. So this is one instance, again, where in algebra, you have to master previous skills in order to unlock new skills. If 1.1 and 1.2 were not good for you, you're going to have to review those in order for us to really take advantage of what we've got in 1.3. Otherwise, you know, it's like you're building a house with no foundation. The entire thing is going to fall apart. Now, there are some special things. We've got an identity, and then we've also got no solution. So I'll show you what an identity. So if you're solving a problem and then eventually you get to an identity, then the solution that you would write down is infinitely many solutions. Quote, that's what you would literally write. So for example, if I start off with this equation, 2x plus 1 equals 2x plus 2 as a given, well, the first thing I would do is simplify. And that would be distribution. 2 times x is 2, 2 times 1 is 2. And that gets me to a line that says 2x plus 2 is equal to 2x plus 2. This is an identity. We've got something that is equal to itself. The left side and the right side of the equal sign are exactly the same. And that's when we would write infinitely many solutions. And what's implied here is that it doesn't matter what you put in for x. The answer is going to, or you're going to get a true equation. You know, if you said x was equal to 0, you would get 2 equals 2. Well, that's true, so it is a solution. If you say x equals 100, then you would get 202 is equal to 202. And that's true as well, so 100 is also a solution. And in fact, it doesn't matter what number you use for x, it'll be a solution. So that's why we say infinitely many solutions. Now the flip side of that is, what if you solve an equation and you get a false statement? Well, in that case, what you would write is no solution. So to illustrate that, what if I had the problem 3x minus 2 equals 3x plus 10? Well, let's try and solve that. Now the first thing that you would probably do is subtract 3x from both sides of the equal sign. And if you simplify that, you get negative 2 equals 10, which is not true. Now the implication here is it doesn't matter what number you use for x, you're going to get a statement that is false. Okay, so let's take a look at this original equation, and let's say if I said x is equal to 0. Well, if x is 0, the left side over here, that's going to be negative 3 times 0 minus 2, which is just negative 2. And then the right side of the equal sign here, I'm going to get 3 times 0, which is 0. And then 0 plus 10 is 10. And that gives me negative 2 equals 10. You can try that out with any number you want. You're going to get a statement that is going to be not true. So that's why we say no solution. There is no value of x that you can substitute that will give you a true statement. So that's going to do it for our notes. Over here, this right here, this is a really important one that I want you to have memorized. This is what we're going to be doing, especially when we look at our problems in our next video where we look at the examples. So we'll see you on that one.